Hello everyone and welcome to Fisimania. In today's video we're going to be doing an experiment. We're going to be doing Ohm's law experiment. We will be looking at the relationship between the voltage, the current and the resistance. Okay, but first before we go into the experiment we're going to be looking at a little bit of theory, okay, where we know from Ohm's law that the voltage is going to be equals to the current times the resistance, okay. So what we will be doing, okay, is going to be plotting and we will be getting data, okay, we will going to be collecting some data by changing the resistance of the circuit, okay, and then seeing how it affects the current, okay. So then what we will be doing in general is going to be plotting the current versus the resistance, okay, and then we will be also plotting the inverse of the current and seeing the relationship between for the resistance, okay. So we will see, like there's a linear relationship between the inverse of the current and the resistance, but there's a non-linear relationship between the current and the resistance, okay. So also we're going to be setting up the following circuit, okay, in which we have a voltage supply, okay, and that voltage supply is going to be connected to a resistance, which is called a rheostat, okay, is a resistance rheostat, and that resistance rheostat is going to be connected to a box resistance, and this box resistance is going to be kind of like a potentiometer where we can change the values for the resistance, okay. So these values for the resistance can be modified, okay, and in this case we're going to be changing that R box between 0 ohms all the way to 90 ohms, and then we're going to be increasing it in 20 in steps of 10 ohms, okay. So the resistance for the rheostat is going to be 20 ohms and the voltage for the power supply is going to be 8 volts. Now we're going to do the setup for the experiment, okay. As you see, we're going to connect the power supply all the way to the rheostat, okay. The rheostat is just what I touched right now, and is that the gray thing, okay, which is going to be 20 ohms. Then we're going to connect from the rheostat all the way to the resistance box, okay, which is this black box that I have in the table. And you'll see, that it has 3 knobs, okay. So those 3 knobs are going to be where we're going to change from 0 to 90 ohms, okay. And the middle knob is going to be the one that is going to change in steps of 10 ohms. Now that I have the setup for the circuit, okay, I'm going to turn on the power supply, and then on the left window, okay, the red digits are going to tell us what the voltage for the circuit is going to be, okay. I'm going to set it up to be 8 volts, okay, so it doesn't change. And as you can see now, the resistance box is going to have 0 ohms, okay, on it. So the circuit only has 20 ohms that is coming from the rheostat, okay. And you're going to see that on the right hand side of the power supply we have 0.463. This is going to be the current on the circuit, okay. So for 0 ohms we have 0.463 ohms. For now, if we change to 10 ohms, you can see that the amperes, the current on the circuit, change to 0.293 amperes, okay. So I'm also going to be using an Excel sheet to put this data on, okay. Now changing to 20 ohms, okay, we can see that it's going to mark as 0.213 amperes of current, okay. If we go to 30 ohms, then we have 0.168 amperes of current, okay. And now if we go now and change it to 40 ohms, 40 ohms give us 0.138 amperes of current. 50 ohms is going to give us 0.117 amperes of current in the circuit. Then we're going to change it now to 60 amperes of current, to 60 ohms of resistance, and that's going to give us 0.102 amperes of current. Changing it to 70 ohms is going to give us 0.090 amperes of current. 80 ohms is going to give us 0.081 amperes of current, and then finally 90 ohms, okay, is going to give us 0.073 amperes of current. Now you can see the data sheet that I've created, where on the left column we have the current, okay, and on the right hand side we have the resistance of the box, okay. And as you can see, we went in increasing of 10 for the resistance box, and then on the left column we can see how that affected the current. Now, if we plot the values that we obtain for this resistance and current, okay, for this circuit, for the resistance box, you can see, that there's actually a nonlinear behavior, where basically we can see that the current is decreasing as 1 over x, okay, kind of like similar to that graph of 1 over x. In order to analyze the data, it's easier to just do it with a linearized data. So what we're going to do in this case now is we're going to linearize the data by taking the inverse of the current, of the values of the current that we have taken. So you can see on the rightmost column what those values are, okay? Now if we go ahead and plot those values, okay, for I inverse versus the resistance of the box, you can see that there's a clear linear behavior in this for these data points, okay? And the equation of the line that we get, okay, is going to be equals to y is equal to 0.128 times x plus 2.1325. Now that we have for linearized data, we have an equation for that linearized data as well, okay? We're going to compare it with the actual theory. Now, going back for a moment to the circuit diagram, okay, we have that the total resistance in the circuit is going to be the resistance of the rheostat plus the resistance of the box, okay. Now, from Ohm's law, we will have that the current is going to be equals to the voltage supply divided by the total resistance, okay. And therefore, this will give us that the voltage supply is going to be divided by the resistance of the rheostat plus the resistance of the box. This is the reason why in the first data that we took, right, when we plotted I versus R box, we saw that we had, a nonlinear behavior. So what we're going to do now is actually take the inverse of this equation, okay, to also make sure that we have a linearized theory. Now, in this case, we will have 1 over the current is going to be equals to the resistance of the box divided by the voltage supply plus the resistance coming from the rheostat divided by the voltage supply. Now, you have to remember, okay, that in this case, what was changing, okay, the independent variable in this case is the resistance coming from the box. The resistance from the rheostat was always constant, okay. So in this case, what we can do now, okay, is compare this equation that we have from the theory with the equation of the line that we got in the previous plot that I showed, okay. Now this equation of the line, okay, is going to be of the form y equals mx plus b, okay. Now, if we make a correspondence between each other, okay, we will have that the y variable is going to be equals to 1 over the current, okay, so the inverse of the current. The slope, okay, m is going to be equals to 1 over the voltage supply, okay. Then the independent variable, right, is going to be, which is what we were changing, is going to be the resistance coming from the box, and the y-intercept is going to be that resistance from the rheostat divided by the voltage supply, okay. Now, comparing these results, okay, with the plots that we have done before, okay, for the linearized data, we see that from the equation of the line, okay, we can actually find what the value of the voltage supply coming from the experiment should be, okay. So we can actually take that voltage supply, okay, and set it up equals to 1 over the slope. And we saw that the slope given before, okay, the value of the slope was 0.1 0.28, okay. So I'm sorry, I wrote it wrong here, but I wrote a different number, but it's actually, the result is going to be correct. The actual value of the slope that we found was 0.128, okay. But as you can see, this gives us 7.86 volts, okay. So which is really close to the actual value that we had set up to come out from the voltage supply, okay. Now, in the same way, we can actually find the resistance of the rheostat, okay, coming from the experiment, from the values of the experiment, okay. Now, since we know the value of the y-intercept, right, which is given by our data, which is 2.135, then we can solve for that resistance of the rheostat by multiplying the y-intercept by the voltage supply, okay, and then we will see, okay, that the actual value is also again very close, okay, and this value is going to be 16.66 ohms. With this, we have reached the end of the video. Thank you for watching.